we go. Excuse me. All right, so the function below is very important in probability statistics. Write a user-defined function that takes as parameters x, u, and s and returns the value of the function evaluated at these values. You can use the numpy function numpy.exp to calculate the exponential. Then write the programming commands which call this function plot between x for x between -3 and 3, with u being 0 and s equals 1 for all values of x. Be sure to label your axis and show the plot. All right. So first thing I'm gonna do is I'm gonna where's my thing? I'm gonna go through this problem real quick and highlight some stuff that catches my eye. First off, it wants me to where's my oh. There. Okay. So this is fluff. Okay, so we need a function, right? And it has these three parameters. We're gonna return a value. So how to make some function, call it p, right? Takes s, u, and s, and then returns a valued function at that value. So we return this like p of x, right? We need to do this program for some numbers between x, -3 and 3, and these two values preset, and then plot it. Right, so right away, we're going to import numpy as np. And we make our function. So def p, we have x, u, and s. Just calculates the y value given these parameters. Right. And now we have to just solve. So our y will equal 1 divided by np square root 2 times np dot pi times s squared, and all of that times np.exp. A little easier. I'll do term 1. Oh. You have negative slash, okay. This would be x minus u squared. Should we put this right here, right? So it's x minus u squared divided by 2 times s squared. And double check the parentheses real quick because this is pretty deep. So we have 1 in the numerator, and then np square root 2 times pi times s squared. Cool. Then exp, we have the negative fraction, and our numerator is x minus u squared, and the denominator is 2 times s squared. Okay. And we'll just return it. So to make our x values, the plot will be more accurate if we give it a substantial amount of points. So let's do x values was np dot linspace. We'll do -3, 3, 100. And y values, we make an array, and we calculate y values. For x and x values, y values dot append y dot p type of x. So run this real quick, make sure that all works fine dandy. Oh, our u value is, what's back here? Our u value is 1, 0, and 1. Run this real quick. Cool. Now we make the plot. To make the plot, we need matplotlib. So we're gonna in from matplotlib import pyplot as plt. One space. In this scenario, you have your start, your end, and how many points you have. So this will give me 100 points between -3 and 3 inclusive. Similar to range, but not quite. A range will be numpy's equivalent of range, right? So I'm going to plt plot x values np dot array y values, and the plt show. There you go. There is our plot. All right. So I had to label my axis and show the plot. So let's do that real quick. Add in stylish elements. So plt.title. I turn it into a numpy array so it's more consistent. I don't think it really matters because it'll work either way. I can try that in a bit though. Title question1 qt.x x label x values plt.y label result of px and plt.legend. We're going to ask for a legend, so we will ignore that. Use one more time. And there you go. There is our plot. If I didn't put this into a numpy array like you asked, and there you go. Actually wondering something real quick. Can I just do yeah, I can do that instead. I forgot about that. Keep forgetting that with stuff like linspace and array, you can directly pass it in and it will return another numpy array at you with all the values calculated. So if I do this entire operation on this linspace, it will give me back a numpy array in which every value in it corresponds to a value from this this array applied to this function. So I don't necessarily need to go through the loop. I can just directly calculate like this. Right, so any questions about this? All right, I forgot. Dr. Ritchie, big thanks to her for helping me today. She'll be helping me answer questions in the chat if you have any. So feel free to ask questions at any time because I may not be able to see the question immediately while typing stuff out. All right, so we'll move on to the next question. Save that. My question 2, I'm gonna skip because I've done that already. 3. Okay, cool. So I have not done this one. All right. So question 3 says to write a Python program that can be used to find the XY coordinates of the local minima and local maxima points between x equals -3 and x equals 5 for the polynomial x cubed minus 3x squared minus 5x plus 25. The output should be the coordinates for both the maxima and the minima. I don't particularly remember how to find local maximum. I'm not going to lie, but the brute force way is to make a bunch of points and then find a point where both values to its left and right are lower than it, or both values to its left and right are greater than it. So I will use NumPy to help me in this case. Import NumPy as NP, and then make our x values. So x values will equal, excuse me, np.linspace -3, 5, and we'll do like a thousand points. All right, I have a function to calculate y, which I put in a doc string. F y of x. Right. And we return x cubed minus 3 times x squared minus 5.5 times x plus 25. Right. We get the y values. Y values equals np. Oh, sorry. Y x values. There you go. Now to locate either local minima or maximum, so points will store in here. All right. So we'll do for y in y values. Sorry, we need to do a regular for I in range, and we'll do 1 to the length of y values minus 1. The particular reason why I'm starting at here and here in particular is that if I have a bunch of these points, right, and I wanted to check with the left side and the right side, if I'm at this index, there is no left side. If I'm at this index, I would have nothing on this side. So I want to start at index 1. This is the length minus 1. So that is my end. You see, end is not included. If I did 1 or I did 7, then I can't really say it's a local minimax because I can't tell what the value is on either side. All right, so if y values, and we're going to do this y values I minus 1, we'll do that I'm going to do y values at I and y values at I. I can chain greater than y values I plus 1. Then the points will append and make a tuple for this. We do x values at I, y values at I. And we can do the same thing the other way around. We flip the signs. So this is local maxima. This is local minima. Right. And these are the points I got. And let's very quickly, let's double check this real quick. Graphing calculator. So the point is y equals x cubed minus 3x squared plus minus 5.5x plus 25, we can see that, so here's -3, like right around, so -3 is this line going down, and then 5 is right here, it's the right point. We can see that there are just 2 points that we're interested in, this one and this one. And if I hover over them, we get, so that's negative 0.683, comma 27.038. If we look at my code, it's a little off. I need to recheck that real quick. And then down here, we have 2.683, and then 7.962. Did I put in the correct X value? Do. Trying to think. 1, -1. Okay, I'm gonna blame this on the rounding error, because if I go to point backwards, it's actually way too small. So I'm assuming I did something I'm not particularly happy about. But the y values are pretty much exact. The x value is a little off. Maybe a lens space was not done so well. Maybe if I make it smaller, maybe. Oh, there you go. If I make my lens space as accurate as it can be, I get increasingly more accurate results. And that is what we're looking for. So this is question 2. Any questions about this one? All right. Obviously, I don't think I can actually finish the whole document at this rate. I can only finish 24 problems. Hopefully, I can get some good ones in though. All right. I want to clear these. That's question 3. I've already done question 4. The original intent of this problem is to use calculus or Newton's method. Oh, yeah. Yeah. If you do know the math way to do it, it's probably maybe a little faster, but regardless, I still do think that manually checking every value will be a bit better. I do kind of remember the lab though. Oh, that takes too long. There's too many points being made. Curious. Yeah. All right. So, question 5. Write a function that would take an input. On the lab you're talking about, there's like the pretty. It's one of the equation labs. You just had to write the equation in the pretty way and calculates derivative. I'm pretty sure. Oh, so close, but not quite. I think you took derivative, you just figure out where y equals 0. But anyways, question 5. Write a function that will take input as a list of numbers and returns the mean variance of a set of numbers. The input can be a list, tuple, or numpy array for a set of numbers. The mean is shown below. Do not use NumPy functions, and you must use a loop. Okay, so we have to use a loop, so we can't use sum or max or mean or var length. It's a little sad, but we'll make it do. Since we can't use, oh, we have to use a loop. It doesn't matter which one you choose because it literally does not matter. We'll just look through and calculate by hand. So, define stats. Use stats. And we'll have a numbers list. This will return the, what does it want from me? Mean and variance of set of numbers. Right, for average, right? We need a total and we need the count. So for number in numbers, total plus equals number, count plus equals 1. Now average will equal total slash count, and that's it. And our variance is just that minus, what is m? Oh, minus the average, got you. Okay, so we'll do variance equals 0. And then variance summation 0. And for number in numbers, I can spell anytime soon. Variance summation plus equals number minus average squared, and then variance summation slash equal total, and we return average and variance. I have an IDE, so I can use, very long variable names. You want to short it down to just variance or something that will probably be less typing on your end. I guess we can test it real quick, see if it works on a regular. So we'll do 1, 2, 3, 4, 5. Oh, right. But Fame didn't print anything because I just want to return. Right, so 3.0, and I believe this will be the correct variance. Any questions about this problem? All right, we're going to go to the next one. 6 I've done already, 7. I've done already, 8 I've done already. When I say I've done it already, it means I've done it in the my review video yesterday. It is already uploaded and the link's already on the schedule. Okay, 9. All right, so 9 says we have this line. So Q09 of PY. So we're to explain what happens through this code when executed, and explain the error if one uses. That's not what I'm looking for. Oh, or okay. So what I want to do is, so we print that, right? Quote, normal quote. Okay, so this will be an error since 5.5 cannot be directly casted into the there you go. Okay, invalid literal. Remember that you can cast a float into an int but not a string consisting of a float into it. So if I did print int float string 5.5, that would work. So if I did this, now that would work. Any questions about this question? Nope, that's still a float. I'm pretty sure. Please. Yep. 0.0 is a float. If it has a decimal point s, it's a float. That's it. Essentially, if the string only has numbers when it can be it, if it has anything but a digit, then it's gonna fail every time. All right, 10. Okay, 10. Just copy the prompts. That's not the prompt, it's a whole document. Okay, cool. So with this string in particular, we will just do words equals, make the string right here, and then word list equals words dot split, and then print words list. And there you go. Any questions about number 10? This is just a review of, do you recognize what split does? All right, I'm gonna head on to question 11. This very slightly overused review question. This was a lab back when I did 102 2 years ago. I'm pretty sure last year it was no longer a lab. I know now it's no longer a lab. This used to be a dictionary lab. Let's get into that one real quick. Close that, close that. All right. So a schematic for converting phone letters to digits mapping is shown in image on the right. Write a Python program that prompts the user to enter 10-character phone number in the format shown, which is 3 things dash 7 more things. And the program places the last 7 alphabetic characters by the equivalent digits and displays the entered phone number in this format, the standard 3-3-4. Maybe example, and they tell you that the last 7 characters are all alphabetic letters. In this case, I'll just assume that the um, yeah, the best thing to do is just to assume that everything could be a letter. Naturally, I want to assume that only the last 7 are letters. So with that assumption. So I'm gonna annotate this real quick. First thing you notice is that we have different formats. We have this format and this format. Easiest way to go from this to that, we're gonna split it and then make the new string. So we're gonna do some character swapping basically. And then we're gonna slice plus out string to fit it in that particular format. And this right here is our dictionary. All right. So with that being said, let's make our phone book, phone pad, yes, number pad. There we go. So pad equals dictionary. Now the question is, do we use letters or do we use numbers as a key? Personally, I prefer using the letters. So, okay, they're all alphabetic characters, which means I can ignore number 1 and 0. So A, B, C, we have 2. D, E, F, we have 3. GHI, we have 4. JKL, 5. MNO, 6. That's not right. That's it. PQRS, we get 7. TUV, 8. WXYZ, we get 9. All right, so this is going to be on dictionary. And the thought process here is that instead of making one for every letter, all I have to do is go for every key and check if um, it exists, if the letter exists in this key using the in keyword. Technically, it will take longer to do this than to type out everything. But if it's an exam question, you don't have particularly that much time to type everything out. It might be a little cumbersome. So I prefer this way. Or do as you wish. Now we're going to replace sorry, we should get input. So phone number equals input. And it doesn't say what. So I'm putting in prompts. Every time you're asked for input, please put a prompt. I am almost certain that every time that there has been input, there was at least 1 point allocated for asking for input using a prompt. So please always use a prompt. I mean, this one's specified, but generally with exam questions, the prompt is specified. Please use that prompt. All right. So we have the input, and now we're going to create the translated phone number. Okay. So parts, we're going to do front and back equals phone number dot split on the dash. All right. Okay. Now all I care about is the back part. The part actually is those 7 letters. So I'm going to say 4 letter in back, and 4 key in pad dot keys. You don't have to say dot keys. I do dot keys, so it's more obvious that I'm trying to grab the keys. You can say 4 key in pad if that makes more sense to you. All right. If letter in key. Oh, new back. What's this? New back. Plus equals pad at key, and we'll turn it into a string. All right. Then now we just assemble the new phone number. Okay. So new number. Okay. The first part is going to be up front. That's safe to say. Now the next part will be the back side. And we want the first 3, so we do this. And then everything else. Dash, U back. Recall. We print dot keys gives you all the keys. It's you don't when you're looping for a dictionary, you can just say this. It does the same thing. It goes through all the keys. I like being a little more explicit with it and specify I'm going for keys, especially since my variable name is key. And I'm gonna run this real quick. It's 800 go FedEx. 800 go FedEx. And there you go. I did not read this carefully. I need to oops. It was it? Phone number is equivalent to the number. Okay, now I run this. Right, 800 go FedEx. And there you go. That is my answer. Any questions about this problem? Very short, sweet dictionary problem, but like weather data, the module 12 lab, your code's highly dependent on how you make the pad. You can just, if you want to save yourself this if statement, you can just make one letter value pair for every letter, and then you just say, you just delete this if statement. But typing this is a lot faster than typing everything here individually as one, so that's why I opted to make a quote unquote small dictionary. All right. So from here, we'll go on to the next question. Oh, why this part? My end is this, right? So I always have this 1, 2, 3, 4, 5, 6, 7. You look at here, right? You do x, x, x dash, x, 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 right? I'm gonna cut it like right here. So and like 0, 1, 2, 3. So I do dot 3, it'll give you this part. And I do 3 this, it'll give you this part. And that corresponds to each side of the, let me change colors real quick. So when it's at the end, right, it's excluded. So it takes in this side, gives you this section. And then on the flip side, if you have it at the front like this, it includes the index. So it gives you everything back here for these 4 characters. And this dash right here is right here. There's that. This goes right here. This goes right here. And the front end, right? This front end, which was this part, is right here, which is where this 800 comes from. All right, let's keep going. 12 already done in the wait, hold on. Yeah, 12 already done in the previous, so we'll skip that. 13 I've also done. 14. Oh, actually I haven't done 14. Okay, so let's do question 14. That is the wrong extension. Right, cool. Right, so I have a text file named peanut.dat of an unknown length on computer's hard drive. The text editor displays the first few lines of the file. Where a programmer reads the contents of this file, then for each peanut number, output to the screen a peanut number, major diameter, sorry, in a format ratio than below. Okay, cool. So I will, okay, first off, I'm gonna just make the file real quick. Click outside, called peanut.dat. It looks like this text is all left aligned. So we do number. How many spaces is that? 1, 2, I'm saying about 4. 1, 2, 3, 4. Major diameter, 1, 2, 3, 4. Minor diameter. All right. And this is 17.61. This is 5.46. We have 2, 16.47, 5.46. Then we have 3, 18.08, 6.12. All right. So that's my file. And I'll put it like right here. Okay. All I have to do is add in a column that says ratio. Considering that this ratio, right, is greater than 1, right? This ratio is greater than 1, which means the ratio is equal to the major diameter over the minor diameter. I don't think it says specifically what a diameter ratio is supposed to be, so make sure you're doing the correct division here, right? We can also see that there's about one space in between, right? And so there's one space padding or in between. And we can also see that for every column is center aligned, right? And this column width is 7. Let me do this. So column widths, right? This one will be wait, we'll do 7 for name. Wait, I'm confused. Let's just do 6. Okay. For name, we'll try out 6. For the major diameter, I won't say it's 8. For minor, it's also 8. Ratio will be 5. These column widths are just the length of each of these numbers, but it's important because with F-string alignment, you have to tell it how long the column will be. One other point to notice is that all these numbers have 0.2f formatting. And there you go. So first thing I would do with this in mind is read the file. Hey, with open peanut.tat, and I just want it in read mode. Oh, sorry, as input file. Okay. If this was a CSV, you can split on a comma, and that'd be so much easier. Not this time. So first we're gonna extract the headers, right? So headers equals input file dot read line. Extract the header. And then we'll clean the headers, right? So we'll do headers equals headers. Oh, let's strip it at the start. Headers dot split on the space, right? I can't really tell how many spaces this actually is, so I'm just gonna do dot split. And then we're gonna go backwards for I in range, length headers -1 to -1, -1. If headers at I equals this, we delete it. Now print the headers to make sure I'm not going insane. I'm going insane. Wait, excuse me. What happened to the file? It's blank. Why is it blank? Did I forget to save it or? Oh, that's much better. Okay. I forgot to save. That's why it was very wonky. So you can see that when I split on the spaces, there's all these like spaces here, right? So you had all these blank spaces within here, right? So the easiest way to delete them is to get rid of them is to go through the whole thing and delete um, the whole thing. I did do split. but split, you have multiple spaces, like if you have like A space space B, this gives you a list. Oh, really? Do, do, do. Oh, okay. I did not know that. All right, cool. So as Dr. Ritchie said, if you do without specifying the space, then it will split on a sequence of spaces, which is nice. If you do end up doing this, which a lot will do, just don't forget to delete all the empty strings, right? But yeah. For loop necessary if it's split on the space. All right, cool, cool. Annotate, delete this real quick. All right, so headers are done. And now we'll just add the new header in. So headers dot append ratio, right? Okay. Now we calculate key ratios. Okay. So ratios instance. Should delete this so it's easier. Key headers and add the ratio. All right. So our major diameters, we'll save in one place. Our minor diameters, we'll save another. Our ratios, we'll save another list. So for line and input file at readlines. Okay. So new line equals new line dot strip. Sorry, line dot strip split. Maybe print this out, you'll see that we get all the strings. Oh, I should probably hold numbers. Hold numbers equals this. Okay, so what I'm going to do is actually an easier way is to unload it like this. So numbers. Oh, I can't. So number, major diameter, major, minor diameter, right? We add to the list. Generator searcher. I have a slightly faster way I want to do this. Oh, we're outputting to the screen. Oh, that makes a lot more sense. I have it right into the file. Never mind. Sorry. Let me redo this. But if we're just printing out to the screen, actually, there's a bit easier way. We will. Okay. So we're gonna print the headers and do print space dot join headers. Okay. Now we have the first line done. Now we will just ratio will equal float, sorry, string float major diameter slash float minor diameter. The reason I kept everything as a string is because when you're using the string formatting without strings, it works particularly with strings. So this is one way. Actually, I don't want to do it a little fancier. Do that, and then ratio equals f string ratio 0.2f. I print my ratio. We get the 3.23, 3.02, and 2.95. So far, our values have been working out pretty well. Okay. Now all you have to do is print the line output. So we do print f. Okay, so it'll be number, right? We're gonna center it at 8. So we have 6885, so it'd be 6. And then we'll do a space. Ratio, not ratio, major diameter up, and it'll be 8 space minor diameter up 8, and then space ratio up 5. If we print this, there you go. There is our output. Everything's centered, everything's formatted neatly. Any questions about this one? I guess if you want to be very picky, you'll notice this number here is actually lowercase. Numbers are first header, so do headers 0 equals headers 0 dot lower, and this way, number becomes lowercase. So if we go back to chapter, so over your string formatting, chapter in Zybooks, but this means to center. Yeah, what Dr. Ritchie said. So the up caret will be your caret is center, less than is left align, the greater than will be right align. Everything here is centered, so I want to center everything. Any questions? Any more questions? Sorry. All right. In that case, we shall continue on. Close that. Annotate. All right. So write a program to repeatedly ask the user to input a student's redheadedness and age. The program will continue to ask for input until negative value is entered, meaning the user is done inputting data. The program should determine a number of redheaded students at minimum maximum ages and a number of non-redheaded students at a minimum maximum ages. The results should be written to a new file using the name studentdata23fa.txt, and file when open text area should look like the following. All right. So if we look at this, right, we have asked for an input until negative value is entered. So, oh, sorry, let me open a new file real quick. This is Q15. All right. So that means I'm going to start with what? I'm going to start with well, it says redheadedness and age, right? Okay. So that means some here I'll have some like color, right? Equals an input. The age will be another input. And then you have while age is greater than or equals 0, right? Ask again, right? And then probably, right, every time you ask, you probably have some line that stores data in probably, in a list, probably. In the list, I'm thinking of maybe we have two lists. We have a red, and these are list of ages. And your non-red, another list of ages. Right? And then you can take these two, right? Your min age you can use the min function, your max age, you can use the max function. Right. So one thing I would note that when you're doing your planning, right, just write down what comes to your head, right? I start with just writing down the input right here, and I managed to make the entire workflow of how to calculate the minimum and maximum ages for red and not red, right? Um, Also, if you want the number of students, right? Number of students, we can use length. Now, we just need to deal with the file, right? So this will be a name, right? So we're going to open this, open in write mode. So I have some like with open blah, 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 W, right? As blah, blah, blah. And we're going to write in here. I'm using a tablet and pen, so I can write the whole thing out. If you rather not write the whole thing out or write shorter than I am, that's completely fine by you. The file, okay, so this can be hard coded, right? So we need to note the spacing, right? This is 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, did I count right? Sorry, I need to recount that. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's about 11 spaces right here. So you make sure it's 11, right? Okay. So neat trick I can do, right? Is that okay? I'm just gonna assume, for the sake of realism, that no one's gonna type enough students that the number goes all the way out here, right? Um, neat trick I've done for this one is that this column length right here be the like, column length. I guess even precise column length equals um, the length of the column name plus 2, right? So I don't have to count, this is 6 plus 1 plus 2 plus 8, right? And plus 2. This is 10, 9, 19, right? You don't have to count all that. You can just you can see that, oh, this is 2 spaces, this is 2 spaces. Oh, this is 0 actually. So my column length will be just this. This you can already determine. You can use 9 plus 2, right? Or 10 plus 2. That's 12. So we're doing sort of formatting columns, right? There's particularly very long column names. If you don't want to risk points or using the wrong number, just copy paste and add a padding. All right. Any questions about the planning so far? All right. So we erase all this. Let's start typing. So first off, right, we're gonna store the data. So red equals list, non-red is not a list. Right, now I'm gonna ask for input. Color equals input. And again, I'm gonna choose a prompt since they don't tell me to, but I will need to have some prompt. Is your student red-headed? And we'll do y/n, right? And then the age equals int, input, enter your age, enter your student's age, right? Okay. So add to list. If color equals y, then red dot append color, else non-red. pen color, right? And we'll have age. Oh, sorry, should be age. That should be age. There you go. Now keep asking. One thing. If age let's equal 0. There you go. Okay. I need this line in particular because the first thing they input is a negative age. I'm not supposed to count that. So this is just in case we ask for a negative at the very start for some reason. And now we do the same thing. And now we can just copy paste this into here. See if we could just keep typing ages as we go. All right, input's done. Now let's calculate the stats. Right, so red min equals minimum of red. Right, red max equals max of red. Red length equals length of red. The non-red min is min of non-red. Non-red max equals max of non-red. Non-red length equals length of non-red length. Non-red, sorry. Okay, so we have all the sets. Min, max, and the count. All good to go. Now, one small detail is that you can see that we're going to left align all our values, right? So what I'm going to do real quick is actually I'm going to make all these strings. Oh. If we're doing any string formatting of alignment, it particularly works with just strings. So we're going to have to do this. Control V, Control V, Control V. Quote, quote, quote. Right. Now we can write to the file. So with open student data 23fa lowercase .txt in write mode. This output file. Okay, so we're gonna write the column names. Right. So we're gonna do output file dot write. Copy paste this whole thing. Great. Okay, these spaces are not helping. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it means 1, 2, 3, 4, 5. This is 2 spaces. Oh, this one. So it's 1, 2. Good. The minimum age 1, 2, and minimum age. Cool. So if I run this real quick, so we have the file. Let's put in some random numbers. 1. Right. For the sake of testing, I will put in some numbers myself. Okay, so if I open up my file, hit this. Right. So nothing, we just have this right now. Now all we have to do is to write everything else. The cursor back here. Write the other lines. Okay. So output file. Not right. And we'll do. What is this? Red line. We'll make an F string. Let's start with red headed. 1, 2 spaces, right? And now we will do the following. we're gonna do this is red min, sorry, red length, and we are going to do something a little cheeky, and we're just gonna copy paste that into here. Red length, let's delete that. Okay, I'm gonna close this real quick. Close this, close that to have space. Okay. Actually, let me run this real quick. We do negative and -1. I open my thing. Oh, I forgot to write the line. Oopsie daisies. Right, I'll just show you after we're done. So first line, here we go. And then second line, it is the red min. And again, we'll do an almost similar thing for one thing. This should be left align. Left align, grab the length from this. And then the last one, I don't really care about the alignment because I'll just directly follow. And we'll just put in red max new line. Rewrite this file to the file output file dot write red line. And you can see that everything is formatted correctly. I just need now copy paste this. Right. I will creatively rename everything to non-red. This would be, what was it? What was the file? It said just not red. Okay. So here we'll put not red with 4 spaces, 1, 2, 3, 4. That will be not. Means not different. Oh, sorry. Non-red length, non-red that, and non like that. We press play real quick. -1n. Oh wait, I put it the wrong way. And -1. And there you go. If you want to make this a little funner, we'll do 100 to 10,000. And then I'll do this one to be 10,000 to 1 million. Yeah, we'll do that. Okay. And -1, you can see the file is still formatted correctly. Any questions? Oh. We're gonna hit you with the ban. All right, cool. Another review, another Twitch ban. All right. Any questions about question 15? All right, let's continue on then. Open this back up. I had a nickel every time I do a Taylor series problem, I'd have $1 million spent. Anyways, question 16, py. these type of summation problems are basically really good for loop practices. Anyways, let's go through this question real quick. So this is a cosine approximation, and this is an approximation, not exact value, right? And we're gonna write a function called t term. So somewhere we're gonna have def t term, lowercase. The input's a value of n, so one parameter. Returns the value of series or only a value of n shown above. Oh, there's more to this prompt. Whoops, let me scroll down. Right. Okay, so we're just gonna return see this be -1 dot dot n star star n times x power again 2 times n, and then we're going to divide that by 2n factorial. So this would be another function or for loop, right? And that result will go right here and nice return. Now we need to continue calculating the summation until the value of the absolute value of the current term is less than 0.01, right? So in other words, we have some tolerance, right? It'll be 0.0001. There's also 1e -5, right? So while my term is greater than or equal to 1e -5, then calculate new term. Add to, oh, sorry, I did in reverse. At term, calculate the new term. That's it. So we make our first term in here. We'll call it, this starts at 0, right? Wait, 0. Factorial of 0 is 1, right? Okay. So we're going to calculate, right? Add, calculate, and then back and forth over and over again. Right. With that being said, we'll start solving. The cheating way to do this is you do. Actually, there's no cheating way to do this. Never. Let's make the t-term function. So t-term function. Define. Actually, we're gonna do a factorial function. So f factorial of n, right? We'll call it x. Okay. So if x equals 0, return 1. That's your edge case, right? Else our product was 1. And for num in range x plus 1, product times equals num, and we'll just return that new product. So example, maybe the factorial of 5, right? Usually 2 times 3 is 6, times 4 is 24, times 5 is 120. Wait, hold on. 1 comma, right? I knew I was missing something. There, 120. Right, now we can make our t-term. T-term function. That's what I get for double guessing myself. All right, so our function, we're going to return -1 power of n. We multiply that by x to the power of factorial 2 times n. Oh, sorry, it's just 2 times n. Wait, x is x comma n, factorial 2 times n, and we divide that by not cosine x to the power no factorial 2 times n, right? So this part is covered by this. This part is covered by that. And this part is covered by this. Factorial to n, good. X power to n, also good. Negative power n, also good. All right. So now we do the ring loop. Oh, get your input, right? Get x. Okay, so x equals float. Okay. Float, and we'll say enter an x value. All right. Now I have a main loop. Okay, so term, say n equals 0. So this is our first, right? The term equals factorial, not factorial, say term, and we put x power n, right? Now, a total equals 0. Okay. So while term is, sorry, absolute value of term, that's greater than or equal to 1e negative 5. I guess you can also say 0 0.12341. Then total plus equals term, and then n plus equals 1, and term equals t term x comma n, and you print output, sorry, print the cosine of x to 2 decimal points is total to 4 decimal places. Run this real quick. Hope we. Oh, I am dumb. Please always check your work and don't make stupid mistakes. I am. All right, 0.5. Did I? This is the 4th time done today. 0.5. Right, let me check this. So -1 power n times x power 2 times n and factorial 2 times n. I am confused. Oh, there's a math module factorial. Maybe I'm just doing factorial wrong. From math import factorial. Nope, I did factorial wrong. So the absolute value of the current term. It's kind of weird. Every year do this question, I get it wrong. I don't remember why I get it wrong. Cosine 0.5. That's in degrees. 0.5 radians would be document settings, radian. Cosine 0.5. Wait. I must have owed something. So -1 power n. So this will flip flop between -1 and 1. Then you have x power 2 times n. And then factorial 2 times n. I guess let's do some debugging real quick. Tall turn. Should be what? Oh, yeah, you're right. 2.5. Yeah. I preached this so much and I still forget to do it. Right, cool. I forget. Negative. When I did -1 power n, it does this first, and then a negative, because this is -1 times 1 power n. That's why I need this instead. Okay, that's my mistake. I need to put that in parentheses. Make it after Richie. Ooh, okay. Yeah, makes so much sense now. All right, any questions about this question other than why it took me so long to see that? All right, let's carry on then. Right, so 17, write a Python program that can be used to graph the following equation for x between x equals 0 and x equals 4. Be certain to include sufficient number of values of x so that a smooth value can be obtained with your plot. Include a graph title and labels for x and y axes. Write a function that is called by your program to find the local maximum and minimum points. Your function should import your list arrays of tuples of x and y, return coordinates, and plot them and output and print. Okay, I'm not gonna do the whole line text thing. I do not believe such labeling is on the exam, but I will, however, draw the actual plot and plot the 2 points. All right. So, question 17. All right, things to note, right? This is our title. We have a Y label. This is the X label. Right. This is using plot. Right. This is also using plot. This is also using plot. This type of point labeling, I don't think so. Dr. Richu had to answer that though. This labeling though, I kind of want to say 100% sure on that one. Because like this stuff, I do not believe is in your quick start tutorial. So if it's not in your tutorial, it won't be on there. If it is on the tutorial, I didn't see it. Well, then you're gonna need to learn it. All right. So, and then here's a function, right? And then your welcome min max, we can do that later. All right. So we do import numpy as p. Make our x and y values. All right, so x values equals np.linspace You can see it goes from 0 to 4. So 0, 4, and do like some really big number like this. All right. And then our y values equal 0 0.1 times x values to the third minus 3 times np dot cosine -2 times x values. All right. We're gonna plot this real quick. I need to from matplotlib import pyplot as plt. Right, so we'll do a graph, right? Right, so the title, so plt.title will be plot of x and y for y equals 0 0.1 times x tower 3 minus 3 times cosine -2x. plt.x label will be x data. plt.y label is y data. And plt.plot x values, y values. And then our color. Oh, already specific color. We'll do blue, all right? And then we graph the graph a line. Graph the min to max. Right. So same way as did before, right? So from the graph, you can see there's one min, one max, right? But just for we'll do points equals this, right? Now, for y value in y values. So we have a local maxima. If I keep doing this wrong, for I in range one length of y values -1. There we go. Okay. If y values I -1 is smaller than y values at I, which is greater than y values I +1, then points that append, and we'll do addiction. If you do lists, right? You can do tuples of points. X values at I, y values at I. And then hashtag local minima. Actually, we can do this. PLT dot plot. So maxima is orange. So do x values at I, y values at I, and the color is orange. And then the local minima. And copy paste this. Flip the sides. So y value is less than both left and side. And we'll do green. Now we'll do plt.show, and we get an error. It's going to be great. It's taking the century. Yeah, cool. Local minima didn't show. Do I really not have a? Let's get this head run. I'm pretty sure if you were like Dr. Rishi said for a previous question, you're supposed to use some calculus for this. I didn't go to calculus route, what also means that my code can still be wrong. But if I added zeros, it'd be 10 times longer than before. That's no good. All right. Trying to figure out just a way I can make this work or not. That's one. Yeah, it's kind of weird that none's happening here. It's the exact same code as the other one. Y values, I. Maybe different color will be better. Oh, it's a bad exam question. Oh, in that case, I'll just skip it. I'll just let. Yeah, I can't scan it. Marker shape. This should be red. Right. This O. Right. This is G. Two markers. And, oh. Okay. I'll just make my own colors. Blue, green. Since I don't remember what orange color is supposed to be. Okay, there you go. There's Malcolm. There you go. Make it up to Richie. So yeah. So we got our dots. We got a blue dot for the maximum, a green one for our minimum. I don't remember what orange is supposed to be. So R is red, K is black, green is G is green, blue is B. Yeah, there you go. There is our graph. Oh. No shortcut for orange. Sad. Just red, green, blue, cyan, magneto, yellow. And there you go. Orange and green. Any questions about this one? It took a little long. Apologies for that. That being said, let's move on to the next one. Oh wait, for this one, right? Um, you should be able to do all this by yourself, right? Or like, if you should be able to look at this graph and be able to identify all the code behind it, right? You should recognize this, right, to be title. This is a plot for 1 point, right? This is another plot for 1 point. This is a plot of a whole line, right? So it's like a list of points. You have your X label here. You have a Y label here. Right? And these X ticks, Y ticks, right? You can see that I didn't have to change them, right? They're the same numbers and down here as well. And then this is a 0 and 4 from before. To be able to recognize different parts. And I guess you might need to know this part. This is from your plt.fig, and then you do your title. All right. And obviously be able to recognize a histogram, right? Your bar graphs and your scatter plots. And of course, you need to know this would be your x values. This can be your y values. This can be your marker shape, right? And potentially the color. This itself is the color, all right? PLT.legend probably for making legends. You can have the labels in here, or you have a label argument in here. What else is there? Maybe you need to know PLT.type layout, or potentially PLT.figure. I think it's like layout constrained is what it's called, right? This is for using subplots. So again, PLT, that's subplot for making subplots. So go over your tutorials, make sure you have this NumPy stuff somewhat memorized, all right? Right, so as the end of the first set, like I said, the other problems I've done already. Um, Speaking of the problems I've done already, let me show you set problems I've done already. tx.ag. Okay, if you go to is tx.ag/exam2 review schedule, it gives you to this link, this drive, sorry, this file. My problems right here, this link right here. Let me use a different color. The problems I skipped are found in this link. They're in the main practice problems, right? And then yesterday's review, when I go over them straight here, just click that. I have added chapters that eventually, if I ever get to it. Today's recording will be put in here, and today's set of practice problems will be put in here. All right. All right, I went in a little early today because after me is Sam and Lily's review with their container files and practice problems, and also Arnav and his friends at 6 to 8. I'm doing his cumulative review and QA. All right. Move this out of the way. Actually, open this real quick. You need our resources. They're listed right here. All right. So our resources are in the review drive, which I'll link. Yes, if you wait, my solutions are in there. Nata Richie has a set of her own solutions on multi-section. It's also the same place where you find the it's also the same place where you find her practice problems, the same problems I'm working on. I can show that in a second as well. My solutions are there. I know she told me that my solutions are very close to her, so you can look at both and see the small differences we did and see how we ended up doing it. The recordings. I'll put my recordings up there too. They're quite big, so it's gonna take a while to upload. All right. They're the links for your use. All right. So the Canvas multi-section. Okay. So if you go to Canvas multi-section, right, and you'll see here something called exam2 information. Click that. All right. And you will see um, the practice problems I did yesterday, which is this set. The practice problems I'm doing today, which is this set. And then this is her solutions for the code. This is just the FAQs from this document. All right. And again, if you go to texas.ag/exam review schedule, you open the link, click this GitHub, and then it sends you to this folder. All right. And you can see some of my solutions here. I'll open one randomly. Right. This was question 1 from the, let me open this problem right here. This is the same question 37 for the packet. All right. You're free to download this. You want to download, right? You just go out here and then you can code and you can download the zip file. You can see all the code for yourself. These are, I do use Python notebooks for the first one, but all the outputs are shown for you, so you don't have to run anything yourself. You can just use this as your reference sheet, right? So it looks like this because I have a dark mode add-on on. If it's off, then it looks like this. All right. You can see that my directory is actually that same folder. So later today, I'll upload all of this onto the GitHub and I will edit the link for the schedule. All right. So back on topic, why we will stop. Right. So we do additional practice problems now. So in here, we're going to do the additional problems. All right. Close that, and then we're going to do. All right. We're going to do question 01. This one. All right. Excuse me. The Lagrangian series expansion for 1 over 1 minus x is blah, blah, blah. So math background. Write Python code as for input of value x to enter value 1 negative, negative 1 less than x less than 1, which computes an approximation to 1 over 1 minus x using the above series. Summation should be continued until the terms added to summation is less than 10 to negative 6 in absolute value, where each term is x raised to a power. All right. So what you have to know is that you're basically adding x to n to itself over and over again. You're basically doing this, and this n is updated, right? So for our input, right, the input of x, which is on this interval, right? So we're gonna just ask for input, right? So you can say x equals input. You're gonna have to assume the input's valid, well, at least it's a number, right? So you enter x, right? Space, boom, boom. Then while not negative 1 x1, we ask again. Remember, this is our valid condition, right? It's a valid condition, right? So if this is correct, then not true is false, and it breaks the loop, right? So while this is false, right, and not false means it's true, and while true means what? I'm going to ask again. Since the loop continues. Since loop continues. Right. This sort of input while loop thing, you're going to see it quite a lot on verification. Same with your try except. I did some of that yesterday. We'll continue my video yesterday for more clarification on that. All right. So now we have to do is just we need to do this calculation. Sorry, not that calculation. We are interested in doing this calculation. All right. So we can serve n equals 0, right? And now term can equal x power n, right? And while term, this is absolute value, right? So ABS term greater than or equal to 10e negative 6, right? So 10 power negative 6, 10e negative 6. You can say total, and I have some total here. Total plus equals term and we do n plus equals 1, and the term equals x power n. And this will rinse and repeat. Then we'll print the value again. All right. That being said, let's do exactly that. So I'm going to get input x equals input, enter x. Then I'm going to validate x while not -1 less than x less than 1. X equals input, enter x. Now we just run this, right? We can do 2, 3, 4, 5, 6, 7, right? We're -2, negative. Oops, sorry. I'm too fast. Right. We're gonna do -5, -4, -3, -2. Wait, hold on. Plus. Not in. Flip. When I do my FRQs, I try some random values in my head to see if it works or not. -5, -4, -3, -2, -1, right? -1.01, right? You have 1, 2, 3, 4, 5, 1.01, and 0.9. Cool. All right. So this works. Now you just need to do the math, right? We have our summation variables, right? So our total is 0. Do not use sum, right? Do not say sum equals 0. Sum is a built-in function, so please don't use it. Total equals 0, n equals 0. Our term will equal x power n. Now tolerance is 1 e -6. Then we do a loop. So here, I'll just print out tolerance real quick so you can see what it looks like. 0. No, just flow. And then we do 10 power -6. Right, so same thing. I think I wrote 10 e -6 on accident. I mean 1 e -6. You can write 10 power -6 if that works for you. It's literally 1 character difference. Okay. I'm used to writing this for reasons. So either way, it's the same thing. So main loop, while absolute term greater than or equal to term tolerance, we will add our term to total, increment n, and then change the term. Then we will print out with x equal x, the approximate value of 1/1 minus x is we'll do total. All right, I'm putting 0.5. I keep forgetting the f string. Okay, there we go. All right, so 1 minus 1 over 1 minus 0.5 is 1 over 0.5, which is 2. You can see my number is incredibly close to 2, and the difference is right here. It's 1, 2, 3, 4, 5, 6. Right? So you can visually see it's about, if I add another number, it'd probably be a little less over here. All right. Now you can try other numbers to your leisure, right? You can do some very funky number. There you go. All right. You can somewhat approximate this, right? 0.78, right? You can say it's around 0.78 is it's between 0.8 and 0.75. 1 over 0.25 is 4. 1 over 0.2 is 5, right? And you can see this number is between 4 and 5. So we are good to go. Any questions so far? All right. So this is a pretty short and simple code, right? Just 20 lines, and that's with like 4 lines and 4 comments. All right. Question number 2. Okay, I want to do this question. I'm going to take a quick break, then we'll come back for more. All right. So we're going to write a Python program that takes 5 integers. So you get 5 integers. All right. The program should check to see if any of the 5 are duplicates of each other. If after all if all inputs are entered and duplicates found, the program should print duplicates, else all unique. There's so many ways to do this, right? You can put everything to a list, right? So you have some list of your inputs, right? And then you use sets, right? You can do if set or length set list not equal to 5, right? Because 5, then duplicates, right? That's one way to do it. You can also do that as you're doing this is like solution 1, right? You can also do another solution is for I in range 5, right? We can have like unique equals true, right? And then you'll do instead of I only do underscore. I did okay. Okay. You're gonna do number, right, equals the input, right? And when we're adding in, right, we say, oh, if num is already in the list, right? Then unique equals false. And then we can say right here, list dot append a num. Then from here, right, into if unique, if not unique, duplicates. And I think you could even make this a set, right? If you make this a set and then add to the set, you can also now check if the length is 5 or not. So lots and lots of ways to do it. This way makes most sense to me. So we're gonna do that. Okay. So get inputs, right? So our numbers equals this. And for underscore in range 5, numbers dot append int input, enter a number, and then check for duplicates. If length set numbers not equals 5, print duplicates, else prints all unique. Do 1, 2, 3, 4, 5, all unique. If I do 1, 2, 3, 4, 2, we have duplicates, right? If I tried mixing it up a bit in between, also doesn't work. I can do a very random order, still unique, right? So this solution uses the fact that sets are, it only will have unique elements. So if your length of your set is not equal to the original list of numbers, then a number was removed because it was a duplicate. And I didn't assign my input to anything because I don't care about storing it in a variable. I only care about putting it to a list. So this is a very short, we use a regular loop. Okay. Sure. Your solution will be unique. I'll write both solutions actually. This is solution one. Wait, loop else, like the for else statement? Sure. All right. So this is solution one, right? And solution two. Note that both solutions use the next four lines, right? So solution two, right? Wait, 104 else? Okay. So for I in range, length of numbers, I could say 5 as well. Okay. So if numbers I in numbers I plus 1, okay, let me just do minus 1. Prints duplicates break. If you want to make a comment of multiple lines, you can use a doc string, a multi-line comment, a multi-line string to be more precise. And then we'll do else print all U, capital U, and this should work. It's not okay. Let's try this real quick. So 1, 2, 3, 4, 5, that works. 1, 2, 3, 2, 4 duplicates. There you go. So let's do this one more time. I'm going to do 1, 2, 3, 4, 1. Also duplicates. All right. So, oh yeah, that's what Dr. Ritchie said. Cool, cool, cool. So what I'm doing, right, is if I am, like, let's say this, right? If I'm at a certain number, let me tilt my thing more so I don't like write so slanted. If I am at, well, if I'm at a number, right, and there's a duplicate of it, that means there is a copy of it, everything to its right. So if this number is inside the rest of the list, that means it's a duplicate. So in this case, one matches with this one, right? So this is true. So this executes, and this else won't execute. Now let's say we had a quick one. So 1, 2, 3, 4, 5. We'll check one first. Right. So we cut it here, right? Check one, sign here. So we're good on this, right? Now we check two. Two is not in this like area. So, sorry. We will check 3, right? And then sign here. So that's good. Check 4, not in here. That's good. The reason I don't check for 5, right? Is if 5 has a duplicate, but it's at the end of the list, right? Any duplicate will be on this side. But a duplicate on this side means that I should have caught it already out here. I'm checking this side, right? Because I never broke, right? I never broke. This else executes. And this executes if loop exits normally without break. There you go.
Sorry, how did you say that the last variable wasn't being checked? Or how did you make sure that it was being checked?
So, like, let's say it's 1, 2, 3, 4, 1, right? If this number has a duplicate, right? But it's a last number, right? you're telling me that, oh, there's a one before it, right? But if my estimate worked, my one beforehand should have checked that there was a copy of it on its right hand side already. So if there's a duplicate beforehand, like right here, it would catch this duplicate and break out of the loop. Oh, it would run this and break out of the loop. If I get to the very end, uh, there's nothing out here anymore. And since none of these numbers, let's fit at 5, right? None of these numbers are checking against this one, trigger this if statement, which means that there's no way that going back and comparing them matters, right? Also, like if you did like without this, right, you'll be comparing a number, right, inside an empty list. This is always false. All right. In that case, it's 4:03. Going to take a quick break so my throat does not die. Well, my throat's not too bad right now, but it's going to die in the next 2 hours. So, maybe a quick break time. Is currently 4:04, so we go to 4:09 p.m. All right. Um, After this, we will just finish the rest of the problems. If you have any spare time, I will open up the room to QA, and I'll probably do the earlier questions I skipped, so you can still see it. Because there's a couple questions I think might be very useful for you all. All right. I'll see you all in 5-ish minutes. Excuse me. All right, let's continue going on. It's a little earlier, but it's okay. It's basically fine. Yep, 4-9. Here we go. All right. So Dr. Ritchie said she'll be leaving pretty soon to take care of her own personal business. So big thank you to her uh, for helping so far. I'll still be answering questions even if she leaves. I might just be a little delayed in my answers since I'm coding at the same time. All right. So we move into question 3, and so write a program to ask a user to enter names and ages of people, stopping when an age of 0 is entered, and not processing that person. The program should collect this information and output an average age, name of the oldest person, and the youngest person, and assume no two people have the same age. Okay, this line usually screams dictionary, except with what we need, we don't need a dictionary at all. So again, we need a while loop of some sorts, right? Oh. We need a while loop of some sorts, and we need to, I'm gonna ask for input, right? So name, age, and while age is not equal to 0, we ask for name and age again, right? And this is our input. Now, while we take input, right, we have our stats, right? So we'll have total age, count, and then our min max, name age. All right. So right here, we can do update the stats. And then we'll do a print. So there's going to be one big while loop in order to do this program, right? So let's start doing that. Question 0.3py. Wait, first is input, right? First we need to have stats. So our total age equals 0. Our count will equal 0. Our max age, max name equals 0, empty string. Our min age, min name equals 0, empty string. All right, and get the inputs, right? Age equals, sorry, name equals input, enter name. Age equals int input, enter age. Excuse me, sorry. All right, now our main loop, right? So while age is not equal to 0, I need to update our stats, right? So total age plus equals age. The count will increase 1, right? And then if max age, it's either an empty string or max age is less than the age, and max age equals age, right? And max name equals name. Update max. Paste this. Actually, I'll just type it a little faster. Update min, if min age, or min age, or min age. Min age equals age. Can't type min name equals name. Cool. And now we ask for the get inputs again, right? So name equals input, enter name, and then age equals int input, enter age. And now we would do our outputs, right? So our average, okay. So average will be NA. Why is this? Why do we max age equals this? We need to set our. Oh, sorry. This is. Yeah. I should change this, but I need a default value for min and max. I would like to set my min and max to my first number, but I don't have my first number quite yet. The reason I say quite yet is because I don't know what min and age are, right? And if my age is 0 at the start, I can't use it. So if it's a value I need to update, or it's just this, right? I need to update the values accordingly. Neatly enough, if this is true, it won't even bother checking this. Because this will throw an error, right? Comparing an integer to a string. But if this ever becomes true, Python is smart enough to know, oh, this is true regardless, so I won't check this. So my average will be NA, right? Actually, I could just do this as well if you want to be consistent. Okay, so like I said, right, if we start age and the get-go is 0, our count is actually 0. And if we do total age divided by count, we get an error. So be very careful with that. So if count is greater than 0, then I change my average to total count, total age divided by count. Now we do output. So the average age is average. Next thing is the oldest person is max name at age max age. Then printf the youngest person is min name name no, name okay age min age. All right, so let's do this to run. So if I do meet and I do 0, nothing. Yay, no error. If I do I don't know, we'll do Sale. She's a bit over me. Do myself, probably younger. And then we'll have Dr. Richie. She's slightly older. Right? And then we'll do Professor Frodo if you're right. And no age. Cool, right? Average age is 21. Yeah. And then oldest is Dr. Richie, and then yeah. It is true. Dr. Richie is just 22. Oh, lightning fast PhD, by the way. Oh, yeah. Any questions about this code? Dictionary? Sure, we can do a dictionary version. Let me copy. I don't just. Okay, let's do this. 1, 2, 3. Okay, I'll do this. We'll do a separate file. I have some time, right? Yeah, I have some time. Right, we'll do Q3 offset. All right. So we'll have our ages. Dict, right? So we have our information. So ages equals dict, all right? Now we get the ages, right? Get the inputs. Okay. So same thing again. So name equals input, enter name. Age equals int input, enter an age, right? And then while age less than or greater than not equal 0, right? Then we'll do ages, age equals name, and then we get input get. enter name, age equals int. Sorry, I'm typing a little slow today. Enter an age. I'm even slow, just like inaccurately. There you go. All right. And now we do the stats, right? So keys, right? So our, I guess, do people. Ages equals people dot key list people dot keys, right? And then max age equals max ages, min age equals min ages. All right, sorry. Okay. If length ages equals 0, print no information, right? Else max age equals max ages, right? Min age equals min ages. Average age equals sum ages divided by length ages. And then from print, the average age is average age. Print the oldest person is people max age at age max age, and then print f the youngest person is people at min age at age min age. Right, so again, if I do myself, I put 0, nothing happens. If I did, again, I'll do Sam, do myself, I'll do ladder, I'll do Richie again, 22, and then we'll do Prof Frodo, 0, and same thing. So, if you do, what, the only reason I can use a dictionary is because it says, you'll see my screen. Okay, cool. Posture works. Okay, so this line right here. Wait, right here. Right. In a dictionary, your keys need to be unique. If you're not unique, you're going to overwrite the value. So, I can leverage this by just making a dictionary where all your keys are the age and we have a name associated with them. So, to find my min, max, and average, right? Dot keys, right? Gives you this like dict viewer thingy majiggy. So you cast do a list, it becomes a list. When you have a list, you can now use max, min, sum length for average, right? And this gives you a key to use, another key to use, another key to use, which I use right here and right here. Actually, this one is not a key. All right. Any questions about this solution? I think the dictionary solution is more elegant. But the original solution is probably what I expect people to do. This actually, I think a dictionary might be more straightforward. I don't know, it depends on what clicks in your brain faster. I always did this because this is how I did it for 3 years. This one though, actually, I think this one's a lot cleaner. It's a nice dictionary. All right, any questions about this, or do I move on? All right, let's move on. So a question 4. Okay. So write a program that will ask, okay, write a program that will ask the user to input 2 integers and calculate the sum between them. Their multiples of 4. Exit if the user provides invalid input. Implement a loop, compute a partial sum. Do not use list tuples and arrays. Wait, it outright says exit if you have invalid input, which means you don't do anything, there's invalid input. So that's very neat. In that case, I will here. All right, in here. Okay, so first let's make out inputs. Let's do our inputs. All right, so A equals input, enter a number, B equals input, enter a number. Now we do input validation. Okay, so try A equals SP2 inverse, right? Int A, B equals int B. Except pass. Else. Okay. So start equals min AB, right? N equals min max AB. And then the revised start equals start what was it? I want 4 plus 4 minus start. What 4, right? So 5, 8, 1. Cool. Right. And then our numbers will be this. All right. But for num in range, revise start n plus 1 is included. Doesn't say. I'm assuming included. Okay. Numbers dot append num. Print some numbers. The sum of the multiples of 4 between between start and end is and to an F. I will also print revise start to make sure I'm not being high with how I'm doing this. If not, I'll do it a different way. Wait, what? Oh. Easy enough change. Make it up for change. All right, cool. I almost lost every single point for that. All right, so we'll do like 1 and like 10. Man, total. Hmm. Oh, whoops. Wait. 1, 10, 12. Here we go. 4 plus 8. We can verify this real quick by printing a number as we go. We'll do 1 to 100, right? Into all multiples of 4. And there you go. Right, so don't read the question too fast. And this the big sentence says do not use list tuples and arrays. Here's your exam. It's like in big column words, but again, please do read the entire problem. Don't rush like I did. Yeah. Any questions about this code? About revise start, this shifts my start to the first multiple of 4. And that way I can just use a step of 4 and I don't have to worry about if the number is 4 or not. If you didn't want to do that, you would just do start n+1 without this, and if num mod 4 equals 0, add it to the total. So nothing super fancy. Cinema line regardless. All right. Any questions? Oh, one other thing. This is try accept. Pass is a placeholder. Pass literally means do nothing. Like just pass. Just kind of don't do anything. I don't want to do anything, right? Because it's just exit the program. So we pass, and then that'll be it. If I put nothing, you get an error, right? So you put something in there to do nothing. Then we do the rest. It works. All right. Problem number 5 is to and it does, right? Wait, 10 to 2, if either of them are invalid, then I don't do anything. Unless you mean like if A is invalid, right? Pass doesn't stop. Pass just says do nothing. But if any of this breaks, right, it goes to accept. And else only runs if I don't get into accept. So a lot of people say, oh, you can put everything inside a try and have an accept. I don't like that. I want to try specifically what would break. Wait, I kind of what I did yesterday, but usually if it's very long code, right, I will try the stuff that will break, and then the stuff that I want to do, I'll put a big else. Well, specifically in this case, because I want to do nothing if I have an error somewhere. All right. I mean, you can place, you can do literally anything. You can say x equals 0, like it does nothing, right? Okay, does nothing. Does something, and then yeah. Pass is just easier to understand why I put it there rather than a random variable assignment. There you go. Question 5. All right. Write the Python code as needed between. Did she re-put exponential? Sorry, I'm looking at this. Why is it exponential? Write a Python code as needed. The print numbers between 1 and 50 that are not divisible by 2 or 3. Okay. For loop. Happy face. Okay. For I in range. Okay. Num in range 151. If num mod 2 is not 0 and mod 3 is not 0, then print num. Right? No even numbers and nothing divisible by 3. Any questions about this problem? Right, prize problem 6. We've done this already, yeah. So I'm just gonna copy paste this code, or not this code. It's actually I'll just write it out again. Why not? Funsies, right? Funsies. So question 6. Close. There you go. Wait, nope. There you go. Okay. So we input. Okay, input numpy. This time is empty. we're gonna label, we have to make, so from matplotlib, import pyplot plt. Let's make a function. So tell p of x, the equation. So define p x, and then we'll return. All right. So 1 times, sorry, divided by np dot square root 2 times np dot pi times, oh wait, I need a UNS, don't I? UNS s squared. That's our first term, right? Now we're going to multiply that by np.exp, np.exp of negative x minus u squared, put down parentheses 2. Okay, be right. Wait, where am I? Right here. So many parentheses. Okay, slash 2 times s squared. Okay, so look again, right? After 1, and then for the denominator, it is square root of 2 times pi times s squared. Okay, we have exp of this term. We can see it is, we have negative x minus u squared divided by 2s squared, and that's negative sign. Right, cool. Okay, now what we have to do is make the x values. So make x and y values, right? So x values equals np, they should be the same. It's just you don't have to import math and numpy now, just import numpy. Hit one space negative 3, and let's do a million. Y values equals p of x values. We're doing 0 and 1. All right. Now we do plot. Okay, so plt dot title. Very important stat function. Plt dot x label. X values. Plt dot y label. Give x values. What else do I want to do? It says label access. Okay, cool. Then we can do plt dot plot x values, y values, and plt dot show. And there you go. A very, very important stat function. Any questions about this? All right, so that is question 6. Moving on, question 7. Wait. Where did question 6 go? Oh, should be here. Wait, did I overwrite 6? No, this is an old question. All right, we're good. We are good. 1, 2, 3, 4, 5, 6. All right. We are still good. So in here, question 07.py. All right. Question 7, where is it? All right. Out of answering a top-down process starts at the top, a bottom process starts at the bottom. Describe differences in the approach to programming. List 2 advantages of each. Okay, so top down, has a focus. Right, top down has a focus on breaking down bigger tasks into smaller tasks, while bottom up has a focus on making making small actions at the start. And then categorizing them into bigger task categories. Yes, okay. That's one, right? Okay, difference number two. Top down can lead to extremely specialized code, since the code is based on the task, on the main task, the parent task, while bottom up can lead to straying away from the original call. These are disadvantages, right? And now you have two advantages of each, right? Top down. Okay, so you have that top down makes breaks down a large project into much more manageable code, so it's less overwhelming. Allows for easier task distribution within a group, right? And then for bottom up, allows you to plan out all the stuff you want to do and build on that. So ensures you can implement all the necessary things. And then I guess this will lets you categorize tasks together. Or I guess lets you categorize tasks or distribute individual tasks based on individual strength. Right? So if you're doing bottom up, right, you have all these individual tasks at the start. If you know if someone's strong on particular things, you can just give them part of certain task or just group stuff up and give them the whole category. The reverse and top down is something big and slowly break it down. This lets you make everything look less overwhelming, and you can just assign a whole parent tree to a person and go from there. All right. Any questions about this one? Okay, 8, I've already done. So we're going to question 9. All right, 9 is an output question. And it says, what is this function output? All right. It's going to print 5, 5. Right. Okay. So where's my pen? There you go. So let's read this slowly. All right. So we're gonna have a big main code. All right. Okay. We see this my func. So let's make a small box for that. So my func. Right. Within that, we have a equals 1. And x points to whatever it's set here. All right. Now here we have an a equals 5. Right. My func a. So this 5 gets put in here, then this x now becomes 5, right? This is the 5. Now, right from A, print x, right? When you print x, when this line executes, you'll get this 5, right? Because it's currently this. Now, when we get to this line, right? When you print A, right, it's going to look at this A in particular and print that out, which is another 5. So this is a scope question, right? So you can see this one is local. It's the local variable. And this one out here is a global variable, right? So even though we have A equals 1 in the orange, right? It's actually just making a new variable called A inside the function. It's not actually accessing the A outside inside that one. All right. Any questions about this one? Alrighty. We shall continue on then. And not just serious question. Okay, I already did this question. So this one I already did today. Okay, this one I did yesterday. Right? That one I did yesterday. This one. All right. Control A this. Oh wait, no. New question. Up here. Q12.p1. Okay. The output of this. All right. It should be 5. Great. Okay. So you split this up, right? You notice that this data, right, is a big list, right? Each list you have a smaller list. Generally make it so it's equal to, okay. So your data, right? You have the big list, and then you have your inner list. You have this one and this one, right? Then in each list, you have these guys, 1, 2, 3, 4. And here you have 5, 6, 7, 8. Right? So data of 1, right, means you want this sublist, right? So this is data 1, right? And then D0 here means you want this sublist. And this is data 1, 0. And then finally, 0, you want this value. This is data 1, 0, 0, which is what you see right there. Any questions about this one? All right, I'm going to continue on then. Our program takes in coefficients of polynomial equation and prints the complete equation. Write a function that takes the derivative of any polynomial equation. Call that function take derivative of the input polynomial. Oh my god. Okay. I'm gonna sit for a bit. This is gonna be a long one. Wait, I'm gonna look at it. Wait. This one's fine. This one's kind of fine. This one's long as heck. Oh, this one's a fun one. This one is okay. So I guess, all right, let's do question 13 then. It's gonna be painful, but If you had Mr. Spears, you've done a question like this before. For one of his labs. All right, so let's plan them. This is gonna take me a while. Right, so I can take in coefficients, right? Okay, so my coefficients, I'm gonna have you input a list of numbers, list of coefficients, including 0, right? That means like if you can do like 1, 0, 2, 4, right? This is x cubed plus x plus 4, all right? Oh wait, 2x plus 4. All right, cool. So when we're formatting, right, we have some things to consider. All right. So number one is starts with 1. The coefficient is 1, right? The coefficient is 1. Then don't add a coefficient, right? Second subcase is coefficient is 0. Don't add anything at all. Don't add anything, right? You also have coefficient is negative. You have a swap plus sign or negative. Fourth thing, this is the coefficient is the order. Means it's the highest order, right? If plus, don't add, right? Yeah, these are 4 main rules. If I think of anything else, we'll go from there, all right? And then derivative is very easy, but we can take care of that when we get there, okay? So let's start. Take coefficients. So coefficients equals input. Enter the coefficients. Dot split. All right. So I print my coefficients, and let's see, like the 1, 2, 4, right? So 1, 0, 2, 4, and 1, 0, 2, 4. Excellent. Now we just need to make the right? Make the function. So this would be function to convert to equation. So def convert or make EQ, right? So we have coefficients. So equation equals to start, right? So for coefficient, for I in range coefficients, all right? So we have edge case, right? Edge case coefficient is 0. If coefficients I equals string 0, continue, all right? I have sign equals plus, right? So edge case coefficient is negative, right? So if coefficient, sorry, edge case is coefficient, okay, I is less than 0, my sign equals negative sign, right? If the coefficient, if I equals 0, sorry, it's not gonna come, edge case, first term, first non-zero term, right? if equation equals blank, right? And the coefficient is greater than 0, then my sign equals nothing. All right. Now we'll just do the math. Okay. Actually, I want to think about this real quick. Okay, we're gonna go through. I want to go through coefficients backwards, actually. The length coefficients. I have that. Okay, my power equals see 0, 1, 2, 3, 4. So length of coefficients. So let me write this down real quick. I need to write something down. Right. So you have like it's 1024, right? It's x cubed plus x plus 4. So we've got 0, so it'd be 4 minus 1, right? So minus 1. Okay. So my symbol will equal, let's say x, all right? So edge case, actually we'll do this. Terms equals this, right? So our edge case is okay. The power is 1, right? If there's f string power. If power equals 1, then our symbol becomes just x. If my next edge is power is 0, right? If power equals 0, then my symbol is nothing, right? Now we combine. So new term equals sign plus space plus coefficient I plus symbol. New terms. Oh, sorry, terms. Append new term. Yeah, space. Let me just try this out. This is a whole lab. I don't know if I can do this correctly. Return dot join terms. So print. Let's do make EQ 1024. Need to do. Oh. I'm kind of higher now. Make so be coefficients. Where is that for? 1, 0, 2, 4. String. Oh gosh dang it, bro. Int in so that int I. Oop, okay. One, 0, 2, 4. All right. So oh wait, I didn't wrote down if I would write it. Edge case. The coefficient is 1 if its coefficients I was 1 and coefficients at I will become nothing. And then my power minus minus I minus 1. There you go. Oh, I can cheat a bit. It's 1, 0, 2, 4. And we have an equation. Let's try, I don't know, -1, -2, 0. Oh, that does not work. I forgot to do ABS int, right? String ABS int, 1, 2, 3. Joys of testing. -1, -2, 0. ABS. -1, -2, 0. Maybe a better way of doing this. Let's see. Okay, I don't think it's an exam problem. This is literally a lab problem, and it's a very long lab. I went to. Must be nice seeing a PT struggle. I should. I see. We'll do and we'll combine it at the start. I can avoid an issue. So add the sign at the start if it's valid. And we don't have to worry about that. No, I hope so not. I think Dr. Ritchie's like if she can do it within oh no, it's not labs, but I mean, this is a ridiculously long lab. X I'm like the number planning I have to do for this is absurd. I probably forgot something again. Oh, that works great. Okay. -1, -2. I don't know, 0. Oh, there we go. Beautiful. Beautiful. -1, -2, 0, -4, 5. Oh, that's pretty. Wait, does he want it if do we want a negative? Oh my god. Do I have to do it? Fine. Well, I can cheat a bit. And instead of adding a space here, I'll let you. I don't want to deal with. I'm so close. Let's figure out this negative sign. Okay. Do some cheating. We're going to remove space if the equation starts with a negative. Okay. So if terms 0 that starts with negative terms 0 equals not showing terms 0 dot split. This should do it, right? Surely. -1, -2, 0, 4, 5. 1, 0, 2, 4. Beautiful. All right, cool. It took me, how long did it take me? 15 minutes, 20 minutes? And this is with an IDE? God forbid you'll have to do this in the actual question. All right, so we have made, and there's probably a test case I forgot somewhere, but let's do it. Oh, that works. Okay, that makes me happy. All right, but anyways, I'm gonna make a derivative. All right, so def make derivative. All right, so take coefficients again. So this will make the derivative. Sorry. Create new coefficients derivative. After you solve this, could you send the code? I mean, it's gonna be uploading the link, right? I'll show the link at the end of this, but all of this code will be uploaded onto GitHub. I put it up here somewhere. Yeah. Go to this link. I had a review yesterday. There's like a link that says my solutions here. That main, well, I want to make a new one for today, but it's gonna be in the big same project. So yeah. So anyways, so make coefficients for derivative. Excuse me. My throat is killing me. I want to do this. So make everything, but shift it over by 1. Okay, so if I have, you want to see I like writing stuff down a lot, and you should too. If 1, 0, 2, 4, right? This becomes 0. Then this becomes 2. Oh wait, so my list just becomes, okay, I have 1, 0, 2, 4, right? Then if it is index 0, 1, 2, 3. If I flip this list, I get 4, 2, 0, 1. So you have 0, 1, 2, 3, right? If I multiply these together, I get 0, 3, 0, 3. I flip it, 3, 0, 3, 0, and I take just these. Wait, doesn't seem very correct, does it? It says 2. Right? Yes, that's 2. So we have the x cubed, right? Plus 2x plus 4. Derivative should be 3x squared plus 2. 2, 1, 0. Right, okay, that's it. So with that in mind, okay. So step 1 is to flip. Okay, so mucose equals coefficients, and we flip them. So -1, right? Yep. Step 2 is to multiply. Okay. So for I in range, length mucose, right? Mu of I equals mu cos I times I. Step 3 is to flip again. So mucose equals mucose -1. And then step 4 is to shift the list. So mucose equals mucose up to the last element. And then return mucose, right? And from here, print the formula, the equation is make EQ coefficients and print the derivative of that equation is make EQ make derivative coefficients. Oh, okay. So we clear that, and then we give this thing a run. We try 1024. Invalid. Oh, wait. Invalid coefficients. Confused. Oh, wait. Did I? Wait, I did split. Oh, flip a converter, flip and convert. We need to multiply. Oh, we need to convert to flip. Whoops. That makes a lot more sense. Okay, so we do flip or int, right? I forgot that my input are all ints. Okay. 1024. What? How? Give me 1 second. Print coefficients. I what? Wait, why did it work for 302? Mucose. There you go. Cool. Where is the print statement? Right, so do 1, 0, 2, 4. Cute. We do that weird -1, -2, 0, 4, 5. And for x cubed, that should be great. All right. So I started around 47, so this took me around 18 minutes to code and debug. And I debugged like several times. So yeah, kind of I think if I took more, if I wasn't on a time limit, I would maybe a little faster or slower, but more accurate trying to say. But the important thing about this one is this is why edge cases are so important. I know y'all probably all hated that one lot data lab we did. It was like you had to write all the test cases. It had to like it was like 50 plus test cases or something. You know what I'm talking about? Um, Heart attack. It was a heart attack data lab. Yeah. Um, this one, the making the equation, a lot of edge cases, and then a lot of weird string processing to make it happen. For those who have Mr. Spears, I did your lab in 20 minutes. It's not to make you feel bad, but it's like at this point now, right? If you redo the lab by yourself, it should take you a bit faster. Now that you are more accustomed to string formatting and planning, hopefully, right? Um, Also like this derivative thing, right? Uh, the thing I wrote out, right? So I started 1024, right? I know that if this is x to the third, um, and then this is 0x squared plus 2x plus 4, right? My derivative is this will be 3x squared, right? Like the one here, right? This is still 0. This is 2x and 0, right? This times that, this times that, this times that, this times that. Note that each of these numbers is an index, right? This is index 0, 1, 2, 3. If I flip this whole list around, right, I get 1, 4, 2, 0, 1, and rewrite my coefficients of um, 0, 1, 2, 3 may not match, right? So this flip, right, the first part, you multiply to the actual coefficients, right? So you get 0, 2, 0, 3, this part. And now note that when you make the coefficients, right, I had the highest power in front. So to reflip the list, so you get, let me call it 3, 0, 2, 0. I know that this 0 is actually 0. It's just a missing value, right? Um, this is just like gone, right? So I want just this. So I will take everything but the last value. And then my function requires strings, list of strings. So I convert everything back to a string. All right. So making derivative, not very straightforward. It's very abusive of using list. If you have me as a PT, you're very aware that I am a very big fan of abusing, utilizing to the full extent, abusing lists and string properties. I I really like manipulating lists and strings. Conveniently enough, your exam has a lot of string processing, right? A lot of string manipulation. A lot of stuff you do, you're gonna have to get very creative. Well, okay, not too creative, but you're gonna have to get somewhat creative of how you want to deal with all the you know, how you want to do the string. How do you want to strip it? You want to split it? You want to slice it, shuffle it, whatever. Right? Any questions about this code? Yeah. Also, like, they are, it's technically cheating, but it works, right? It works, it works. When we look for your exam, it better work. And I don't mean like we're gonna put in the VS Code, and if I can't run it, you get 0. It better look like it would work, right? We're looking for certain things. Like, if this was an exam question for some God forbidden reason, uh, we'd be checking for, did you do all the edge cases? Did you combine them together somehow? Does it remotely look close? Does your logic for derivatives work? Obviously, if I had to read this, I might not get it at the first glance. But yeah, I don't think this is an exam question. It's really long, really tedious. So many places to go wrong. All right. So that's question 13. We're halfway there at 40 minutes. Oh, we're not halfway there. We're 2/3 away there. That doesn't really um, help. All right. For next few questions, we're gonna speed run, and I legitimately mean speed run, because I want to try to finish as many of these as I can before time goes out. I might just stay later, and you'll feel free to leave, as I already said, right? I mean, there's only 4 of y'all left, anyways. All right. So question 14 is the right program. It takes in this data, and then it's a dictionary. Okay. So patient dictionary. Right. So patients equals blah, right? And take input. Right, so for I in, okay. So get number of patients. Right. So num of patients equals int input, enter the number of patients. Right, and then get input and add to dict. Right, so for underscore in range num of patients. We're gonna see that all the names are unique, right? So name equals input, enter the name, symptoms plus input, enter the signs and symptoms. Then we'll do patients, name, symptoms, and then get user data. Prints. Oh, okay. So name or patient name equals input, enter name of patient, and print data for slash quote a patient name is, and then we'll do slash quotes again. Patients, patient name. Do a quick example. We'll do 1, right, to Anthony, and then place league. Okay, and there you go. Any questions about this one? Very simple frontier dictionary, right? All right, next, question 15. Fifteen is too broad. I can't answer that. Wait, can we do 16? q16.py. All right. Nope, sorry, close this. Question 16 says create a function num condition that which adds two integer values and returns true both add up and multiply to more than 10 and 20 respectively. And false if neither of these conditions are satisfied. If one is satisfied, it returns which condition is satisfied. Use test cases in doc string. I'm not using test cases. That's nah, no. All right. So define num condition. So do x. Actually, don't take anything. As for two values, it verifies sum exceeds 10. Product exceeds 20, right? So A equals int input. Enter the first number. B equals int input. Enter the second number. Okay. Is okay. Valid sum equals a plus b. Larger than 10, right? Valid products equals a times b greater than 20, right? Okay, so if valid sum equals valid product equals true, return true. How do you return which condition? Okay. If valid sum, return valid sum. If valid product, return. Okay. So if I didn't call the function. Okay. So if I did like 1 and 2, right, I get nothing. Check some comments. Yeah, input. Verify. Says both are wrong. Both are true. Both. Okay, both are false. All right. Not that one. How does underscore in range? Oh, if you underscore is a valid variable name, remember? Because your variable can start with an underscore. Usually, if you do a for loop but you don't use the loop variable, convention is use an underscore. Because underscore is a valid variable name. All right. If we do 3 and 10, that's not it. 3 and 10. Oh, I should print the condition, right? Print num condition. That would be very, very useful. Okay. If I did 3 and 10, we get true. Yay. If I did 2 and 5, we get false. If I did 10 and 2, we get just a sum. And if I did, wait, 7 and 3, a valid product. Any questions about this one? Okay. Keep going. I'm not doing 17, 18. These are ridiculously long. External libraries. What? Okay. No. No. Big no. Okay, I might do it again if I have time. But we'll see. Question 19. Yep. Any questions? All right, effect. Okay, you probably can tell I haven't seen these. I haven't seen this set before, so I forgot to say at the beginning, but I wanted to not have done these before, so you'll have a better idea of how it looks when someone's doing this for the first time. Me in particular, that's why I'm also skipping questions I've done before because it's not really fair. But these questions I haven't seen before, or the earliest I've seen them was last fall, which means I've forgotten them already. So, yeah, hopefully it's been good seeing me suffer on certain questions. All right, all right. Question 19 is return a fused number of coins plus change. Take input change required when blah blah blah. All right, so okay, this is what we call a greedy algorithm, and it means just so it's all of like algorithms. We call it, this one we call it greedy because we're going to be literally greedy. So the change, right, is dollar coins. So you have the 100 cent, right? You have 25 cents. Well, I haven't written 25 cents in so long. 10 cents, 5, and 1, right? You're going to check for all the hundreds, then the 25s, then the 10, then the 5, and the 1, going this order. Since we're just going to do the biggest one, we go down the list. It's called a greedy. Do you know why it's called greedy? No, not necessarily, but this is how you're gonna do it. It's like how you do in real life, right? You start with the highest one, the next highest one, so forth until you're done. All right. It was also a lab that was very similar to this. Right. So first is take input. So the number, let's see, change equals float it input. Sorry, enter the change. Right. So the the cents, right, will equal int change times 100. Okay, now we don't have to do a floating point error. Now we can just go on, right? So record it. So we'll just slowly divide and conquer. So okay, so dollars equals cents mod 100, right? That cents will slash equal 100, right? And quarters equals cents mod 25, cents slash equal 25. Dimes equals cents mod 10, cents slash equal 10, right? And then nickels was cents mod 5. Wait, sorry. This mod, this mod, this mod, this. Then the pennies is everything left over. Cents mod equal mod 5. All right. Okay, so we just print. You will need, if you have to sneeze, dollars, dollar coins, quarters, excuse me, dimes, nickels, and pennies, pennies. All right, let's give this a go. Do like 1.38. So $1, right? And then it's 25 cents and then 13. Great. Any questions about how this code works? All right, let's move on then. Q20 to PY. Okay, we're almost there. We're almost there. All right, define a function and takes a word and counts the number of consonants and vowels. Use this function to perform the action for each word by the user. Okay. Let's do it. Let's do a fun way. We'll do a fun way. So def count. Def yet count. Returns number of vowels and consonants in the word. Right. So num vowels equals word dot count a plus word dot count of vowels. Oh, sorry. Word equals word dot lower. Vowels equals a e I o u y. For vowels. This is probably a little unnecessary. Why not? Vowels plus equals word dot count. Vowel. Turn num vowels like words minus vowels. Let's count. Oh, does this work? Right. So free vowels 1, 2, 3, and 4. Right. But now we just need to so adjust the word. Literally count with your numbers. All right. Now we do this for the words. Okay. So yeah, input. Oh, I'm gonna make this very fancy. Here's some board. NumPy SNP. Woo. All right. No, actually, no fancy. Too fancy. All right. So words equals input enter sentence dot nope dot split nope that's how I do dot split yep okay. Total vowels equals 0, total consonants equals 0. All right, so for word in words, vowel count, bye-bye, vowel count equal what? Vowel count, consonant count equals yet count word total vowels plus equal vowel count total constants plus equals consonant count. Right? Print there are total vowels and total consonants. Okay, so if I run this and I just do a bunch of Anthony's, Anthony. Yep, 9 vowel, 12 consonants. any questions about how this code works? Dot count literally gives you how many times it literally gives you how many times the string appears in the string. So I find this much more efficient than a nested for loop, or it makes more sense to my head. So I recognize dot count faster than the if statement. All right, I show it to you one fun. Oh, I'm the only one to Zoom. Just the Twitch people left. All right, last question. Well, in this packet, question 21 by PY. Oh, it's a total number of letters minus the vowels. Because every letter not a vowel is a consonant, so I just did length word minus vowels. I'm also assuming there's no numbers, like there's no like 1, 2, 3 appear, just a list of words. Speed. Make speed of 20 minutes left. Okay. Question 21. Write a function insert number to an order list that goes from small to big so that the list still goes from small to big. Turn out big list. All right. So assume this is the order list. All right. Numbers equals 1, 2, 3. Let's put space like 4, 5, 6, 7, 8, and 10. 10, right? Right. Insertion code. If I insert number, right? And a number. Okay. The easiest way to do this is you want to insert it when the number is equal or less than, right? So for vanillas as well. Okay. So for I in range with numbers, all right. If numbers I is less than or equal to number, numbers dot insert I number return numbers dot append number. All right. Now let's do insert number 3, and we'll print numbers. All right. Yep, if 3 goes incorrectly. Now let's try like 4. Beautiful. Try 1. Beautiful. 11. Beautiful. 9. All right, cool. If you don't want to use the list function, you can just say numbers equal numbers of I plus number plus numbers I that, and you'll get the same exact. Wait, what? Oh, I shouldn't do that. So it makes a new list. New. Yeah. There you go. Any questions about this code? All right. this question I skipped is in the other problem set. So this problem I skipped also in another problem set. This problem I skipped, number 6, also in the problem set. 7 is also in the problem set. 8 is also in another problem set. 12 is also in another problem set. 13 is in another problem set. This is also, well, this was repeated. This is repeated as well. Also another problem set. This one's one that gave me pain. I guess, let's see, 18 is ridiculously long. I guess an 15 skip it, it's really, oh. All right, well, okay, fine. I don't know how I'm gonna do this. All right, we're gonna do a new file. I'm gonna call it grades1.txt. All right, and it says we'll just put in some numbers in each line. All right. All right, I'll do this. Okay. So this is question 15. All right. Uses grades 1.txt instead because another problem uses grades.txt. All right. So we can do simple file open, right? With open grades .txt in read mode, not write mode, right? This input file. Right, so grades equals the following. Yeah, okay. Grades equals input file dot read dot strip dot split on the new line, right? So this is to extract the grades and then convert strings to floats for I in range length grades. Grades I equals float grades I, and then calculate stats. So print f the average is sum grades divided by length grades. F the highest score is max grades. Print f the lowest score is there you go. And yeah, beautiful. Any question about this problem? You can use root lines. I prefer to, it's all like this, right? I'm more like an individual task one by one. I rather read everything then convert to float rather than read and convert one by one. So what I did was if you read this one big string, right? It's gonna be like 10, new line 200, new line 20, new line 12, new line 389, new line 23, new line 8. So, or I guess somewhere here, 8, right? So you read the whole thing, then you strip it to take care of the end right here. And you split the new line, you'll get a list of each of these strings. If I print grades, you'll see this. There you go. All you have to do is convert to floats and then use your sum length max min to make your average max and min scores. All right. All right. We'll do, okay, I guess we'll do 18 or 17 then. Q17 of PY. All right. So we're gonna open our file. Sorry, excuse me. I need to so this is yields.txt. Okay. With open yields.txt append as output file. All right. Now we are going to ask for inputs. So ideal mass goes float input. Please enter the ideal mass. Experimental mass. Float input. Float input. Please enter the experimental actual mass. All right. I'm gonna look up a percent error supposed to be. Percent error equation. I keep mixing up which one's which. Its actual is okay. Yeah, I was right. Okay, so the percent yield equals 100 times ABS experimental minus ideal over ideal. So print calculate yield output to file and console. To console and file. Percent yield is percent yield percent output file dot write percent yield percent slash f. All right, so let's do random number, also random number. Okay. This is a percent error. 100 minus this. Right. Do 100, 100. Yeah, and then we do cool. So yields, we had this file. All right. All right. So, any questions about this problem? I think I've done 18 before. I need to hunt it down though. Let me give me a bit to see if you can hunt down that question. So we go to GitHub. What I'm gonna do first, I'm gonna commit all these changes. So finish additional problems. So in my GitHub, so put the link in here, and I'll put the link in Twitch as well. Okay, so when you go to the link, you should see something that looks like this. Okay, all problems today will be in this more exam 2 practice problems. So you can go in there. There's your problem set, and here are all the questions I've done. All right, so these are the main problems, and these are the additional problems in the PDF. All right. So English is hard. So yeah, let me here, do this. TX exam review schedule. Practice problem solutions will be found here for the second PDF of prompts. And then this control K. Apply. Right. We're going to change this. Right. Beautiful. Right. Click this, open this up, and there you go. All my problems. All right. When I am, right, so I'm gonna end the Zoom meeting soon. But when I end the Zoom meeting, it's gonna take me like several hours for this. It's gonna take me like 3 hours for the file to convert, and it's take YouTube like 9 hours to convert this thing into YouTube. So hopefully sometime tomorrow afternoon, you will see a YouTube link right here. All right. As a reminder, we have Salmon Lilies coming up. Salmon Lily, they're coming up, and you have Arnav and his friends. I don't know them, so I should say this. They both have their reviews. No, this was there's tomorrow. Never mind. So after me, that's just Salmon Lily. If you want more stuff about containers and files and practice problems, go join their Zoom or wait for their review video that will be right here. All right. Once again, thank you for coming to the review. This concludes my review, and I hope you all the best on the exam. If you have any questions, feel free to ask me on Discord or email. All right. Other than that, have a great Thanksgiving break. Or I guess last 2 days of class before Thanksgiving break. If you're watching the video, I hope you're doing great as well at home or wherever you are. And good luck to your exam whenever you take it. All right. Bye bye.